section of chapter 7. This is just the same deal. It's more proportions, more cross multiplying, that sort of math. There's a little bit of factoring and FOIL that comes into this play, so just be prepared. Okay, first thing I'm going to throw in is the Sierpinski triangle. This happens to be some sort of application of similar triangles, if you will. Every one of these triangles in this picture are all equilateral triangles, and they're all similar to the big triangle in some way or fashion. The way it's created is by connecting the midpoints of the triangle before it, and it makes this really cool pattern as you go, and eventually it should keep going on forever and ever and ever, because you should be able to keep splitting things in half and never get rid of the segment altogether. So this is just one thing. It's in art and some other things, but just one application of similar triangles. It's pretty cool. Alright, the theorem for the day is the side splitter theorem. If a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So what this is saying is the little triangle on the top is similar to the big triangle, and so that's why we say A over A plus B, and then C over C plus D. You can also say A over B and C over D, like a little shortcut, if you will. Okay? Depends on what information you are given and how to set it up. Alright, so to do this, we could do x over 16 and 5 over 10. Or you could do x over x plus 16 and 5 over 15. It'll give you the same result. So if you look at this, 5/10 is a half, so x has to be 8. If you're not sure about that, you can cross multiply and do your math, and that should come out to be 8 as well. Alright, for this one, do x plus 1.5 over x, and then 5 over 2.5. So we cross multiply first. So we get 2.5x plus 3.75 equals 5x. So subtract 2.5x over. And then divide by 2.5. You get 1.5. Some of these you can figure out just by looking at them. Some of them you have to do a little math too. Just depends on what you're looking at. Alright, a corollary to the theorem. If 3 parallel lines intersect 2 transversals, so the transversals are the lines that are not parallel, then you've got at least 3 parallel lines. You could have more. Then the segments intercepted on the transversals are proportional. So these are proportional to these. So you just say A over B equals C over D. Nothing too crazy. Okay, so for example, this is a sailboat, and sailmakers sometimes use a computer to create a pattern for a sail. So the computer, they set it up, they cut out the panels of the sail, and then they have it sewn together to form the sail. We need to know what X is and what Y is. Okay, if you notice, on the right side, everything's 1.7 except we don't know what Y is. On the left side, they're not all 2. So then we're not really sure what X and Y have to be just yet. But you can set up a proportion. So up here, you can make a proportion, right? 2 over X equals 1.7 over 1.7. That should be really easy to see. X is 2 feet. Alright, so then we can look at the bottom portion. Do 3 over 2 equals y over 1.7. And cross multiply. And then divide by 2. And we get 2.55, so 2.6 feet. It's a little more than 1.7, not double, but a little bit more. Alright, same deal here. Match things up, make a proportion. So you can do 16.5 over 15, and then y over 26. And you can do 15 over x, and 26 over 30. And then we can just solve. So we can do 16.5 times 26, and divide by 15, you get 28.6 for y. And on the bottom one, you can do 15 times 30, and then divide by 26, and we get 17.3. Okay? Same stuff we've been doing pretty much. Alright, triangle angle bisector theorem. So if a ray bisects an angle of a triangle, so down here on that bottom corner, you notice those angles are congruent. So the line going through the middle is a bisector. Then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. So here's the deal. You can set up your proportion. You can go C over D equals A over B, like I've got there. You can also do C over A and D over B, or flipped over on both of those. Okay, so we'll put C over A, D over B. The thing you can't do is go C over B, D over A. See how they cross over when you write them? Those don't work. Okay? So they have to match up one way or the other. Okay? Let's try one of those and make sure. Alright, so we can do 8 over x equals 5 over 6. Or we could do 8 over 5 equals x over 6. Either one of those will give you the same answer. Okay? And you don't have to do both of them. You just have to do one of them. So when you solve this, you get 9.6 either way. Okay? But if you would have done 5 over x and 8 over 6, wouldn't work. Okay? You're going to get something completely different. Alright? One more. So we'll do this one, 5 over 3.6, 8 over y. You could do it the other way too, it doesn't matter. Alright, so we solve, and I get 5.76, so we'll call it 5.8. Alright, and that's the end of chapter 7.